The repetition of sound caused by the reflection of sound waves is called an echo. When a person shouts in a big empty hall, we first hear his original sound. After a little while, we hear the reflected sound of shout. This reflected sound is an echo. So, when we hear an echo, we are actually hearing a reflected sound, a short while after the original sound. Thus, an echo is simply a reflected sound. An echo is heard when sound is reflected from a hard surface, such as a tall brick wall or a cliff. A soft surface tends to absorb sound, so there is no echo. We know that the speed of sound in air, at 20 degrees Celsius, is 344 meters per second. So, if we shout at a wall from 344 meters away, the sound takes 1 second to reach the wall. The sound reflects from the wall and takes another 1 second to return to us. So we hear the echo 2 seconds after we have shouted. It has been estimated by scientists that if two sounds reach our ears within an interval of 1/10 of a second, then we cannot hear them as separate sounds, they appear to be just one sound. The human ear can hear two sounds separately only if there is a time interval or time gap of 1/10 of a second or more between the two sounds. This means that we can hear the original sound and the reflected sound echo separately only if there is a time interval or time gap of at least 1/10 of a second or 0.1 second between them. The speed of sound in air increases with increasing temperature, so the speed of sound in air will be more on a hot day when the temperature is high than on a cold day. Since the speed of sound is more on a hot day, therefore, an echo is heard sooner on a hot day than on a cold day. If there are several reflecting surfaces, then multiple reflections of sound take place and hence several echoes may be heard. For example, rolling of thunder is due to the multiple reflections of sound of thunder from a number of reflecting surfaces, such as the clouds and the land. If a sound is made in a big hall, the sound waves are reflected repeatedly from the walls, ceiling, and floor of the hall and produce many echoes. The echo time is, however, so short that the many echoes overlap with the original sound. Due to this, the original sound seems to be prolonged and lasts for a longer time. In other words, a sound made in a big hall persists or lasts for a longer time. The persistence of sound in a big hall due to repeated reflections from the walls, ceiling, and floor of the hall is called reverberation. A short reverberation is desirable in a concert hall where music is being played because it gives life to sound and boosts the sound level. But if the reverberation is too long, then the sound becomes blurred, distorted, and confusing due to the overlapping of different sound. Modern concert halls are designed for the optimum amount of reverberation. The excessive reverberations in big halls and auditoriums are reduced or controlled by using various types of sound-absorbing materials. Some of the methods used for reducing excessive reverberation in big halls and auditoriums are as follows. First, panels made of sound-absorbing materials like compressed fiberboard or felt are put on the walls and ceiling of big halls and auditoriums to reduce reverberations. Second, carpets are put on the floor to absorb sound and reduce reverberations. Heavy curtains are put on doors and windows to absorb sound and reduce reverberations. The material having sound-absorbing properties is used for making the seats in a big hall or auditorium to reduce reverberations. The soft and porous materials are bad reflectors of sound. The soft and porous materials are actually good absorbers of sound. For example, the materials like curtains, fabrics, and carpets are bad reflectors of sound, but they are good absorbers of sound. The bad reflectors of sound do not give good echo of the sound falling on them. They absorb the sound, and hence muffle or silence the sound falling on them. We can hear more clearly in a room having curtains because curtains are bad reflectors of sound. The curtains absorb most of the sound falling on them, and hence do not produce echoes. On the other hand, in a room without curtains, there is a greater reflection of sound, due to which some echoes are produced. These echoes cause a hindrance to hearing. In addition to curtains, carpets and sofa sets in our rooms also reduce the formation of echoes by absorbing sound waves. From this discussion, we conclude that some of the sound-absorbing materials or objects which make our big rooms less echoey are curtains, carpets, and sofa sets.